Good morning, scholars. Welcome back to the channel. This morning we're looking at dividing mixed numbers at the grade 4 level. So the fractions are not too complicated, pretty simple fractions, but still mixed numbers, and we're dividing. So let's read through the notes and then I'll explain. How to divide mixed numbers, and this is at grade 4 level. Change the mixed numbers to improper fractions. So that's the first thing. We're dealing with mixed numbers, we change them to improper fractions. If you don't know how to do that, or if you don't remember how to do that, you can check out the videos that I have on changing mixed numbers to improper fractions. I also have changing improper fractions to mixed numbers. I have how to reduce fractions. All of those skills you're going to need. So if you're not too versed on that, you might want to go back and refresh yourself on those videos and then come back to this one. So we change the mixed numbers to improper fractions. We are going to retain or keep or write back as is the first fraction. So we write the first fraction as it is in improper fraction form. Then we're going to reciprocate or invert the second fraction. Change the division sign to multiplication sign, and then we have to reduce. We have to see if we can reduce the fractions and multiply as usual. Now, why are we changing the division sign to multiplication? Why are we reciprocating or inverting the second fraction? Because it's a mathematical principle that when we are dividing a number by a fraction, we get the same result as if we were multiplying that number by the reciprocal of the fraction. So by reciprocal we mean what is in the numerator goes to the denominator, what is in the denominator goes to the numerator. So to divide by 3/4, 3/4, is the same result as to multiply by 4/3. So using that convenience, that mathematical convenience, we just think of the division as a multiplication problem. And we know that we're going to change the sign to multiplication. All we simply need to do is to invert the second fraction. To divide by a number is the same as to multiply by its reciprocal. That is a principle of mathematics. So since they are mixed numbers, the very first thing the first thing we do is to change those mixed numbers to improper fractions. So we multiply the denominator by the whole number, add the numerator, and put that back over the denominator. Like I said, you can check out the video that goes through step by step how you do that. So 2 ones 2 plus 1, 3/2. Change the division to multiplication. 3 2 6 plus 1, 7/3. But what does it say we are to do? Reciprocate the second fraction. So instead of writing the 7/3, we're going to write 3/7. And now we can go ahead and see if there's anything in the numerator that we can use to reduce anything in the denominator. In this case, we can't, since 3 can't reduce 7 or 2. So now we're just going to go ahead and multiply the numerators out. 3 3s are 9, 2 7s are 14. 9/14 is already in its simplest form. It cannot be reduced any further. This is our final answer. Here we have 2 1/2 divided by 1 1/3. So we're going to change them to improper fractions. We're going to go ahead, change the division sign to multiplication, and invert the second improper fraction. 2 2s 4 and 1, 5/2. Change the division to multiplication, since dividing by a fraction is the same as multiplying by its reciprocal. 3 ones 3 and 1, 4/3. So we're going to reciprocate that. It's going to become 3/4. 5 3s are 15 and 2 4s are 8. That's an improper fraction, and we like to put our answer in a mixed number form or a common fraction form. So 8 goes into 15 once, remainder 7 over 8. 2 and 2 ninth divided by 1 and a quarter. 9 2s 18 and 2 20 over 9 times 4 1s 4 and 1 5 over 4. The reciprocal of that is 4 over 5. Now looking at this, we see where 20 and 5 can be reduced. We can use 5 to divide into both of them to reduce them. 5 goes into itself once, 5 goes into 20 4 times. 4 4s are 16, 9 1s are 9, 9 goes into 16 once, and there's a remainder of 7 over 9, which is in its simplest form now. It cannot be reduced. So the final answer is 1 and 7 over 9. 3 and 2/5 divided by 10. So the 10 is a whole number, but remember, any whole number can be expressed as a fraction itself over 1. 10 over 1 is the same as 10. So we only have to change the 3 and 2/5 to an improper fraction. 5 3 is 15 and 2 is 17 over 5. We're going to change the division to multiplication, and the reciprocal of 10 is 1 over 10. Since 10 is 10 over 1, the inverse of that is 1 over 10. 17 times 1, 17, and 5 times 10, 50. This actually, as big as it looks, the numbers look big, but it's actually in its simplest form. Because other than 1, there is no number that can reduce 17 and 50. 17 is a prime number, so only 17 can go into itself, and 17 cannot go into 50 without a remainder. So this is in its simplest form. 3 and 2/3 divided by 5 and 1/3. So we're changing them to improper fractions. We're changing the division sign to multiplication. We're inverting the second. 3 steps. Change them to improper. Change the division to multiplication. Invert the second one. So 3 3 is 9 and 2, 11 over 3. Change division to multiplication. 3 5 is 15 and 1, 16 over 3. The reciprocal of that is 3 over 16. Now we see where the 3's can reduce each other. 3 into 3, 1. 3 into 3, 1. 11 times 1 is 11, and 1 times 16 is 16. This is the simplest form. 11 is a prime number, so only 1 and 11 can go into 11, and 11 can't go into 16, so we can't reduce 11, 16. This is the simplest form, and that is our final answer. 1½ divided by 4 and 1/3. Change them to improper fractions. Change the division to multiplication. Reciprocate the second fraction. 2 1s, 2 plus 1, 3 over 2. Change the division to multiplication. 4 3s, 12 and 1, 13 over 3. The reciprocal of that is 3 over 13. 13 is a prime number, 3 can't go into it. 2 is a prime number, 3 can't go into it. So we have 3 3 is 9, 2 times 13, 26. That is in its simplest form. There's nothing that can go into 9 that can also go exactly into 26 except for number 1. And we know it makes no difference to divide by 1. So this is our final answer. 6½ divided by 4/5. Okay, so we are changing them. This time we only have the 6½ to change to an improper fraction. 4/5 is a common fraction. 2 6 is 12 and 1, 13 over 2. Change the division to multiplication. Invert the 4/5 so it becomes 5 over 4. Right? And now 4 can't go into 5 or 13. Both 5 and 13 are prime. So nothing down here can go into them, and they can't go into anything down here. So 13 times 5, if you go to the side, get your rough work paper, multiply 13 times 5. I believe you're going to get 65, and 2 4s are 8. That's an improper fraction. We don't leave our answers in that form. So we say we're going to change it to a mixed number. How many times can 8 go into 65? 8 times, because 8 8s are 64. Therefore, we have a remainder of 1, and we put it back over the 8s. Right? So we're doing pretty well. We're going through them pretty well. 2 and 1/7 divided by 4 and 1/3. We're changing them to improper fractions. Then we're going to change the division to multiplication, and we're going to invert the second improper fraction. 7 2s are 14 plus 1, 15 over 7. Change the division to multiplication. 3 4s are 12 plus 1, 13 over 3. Reciprocate that. 3 over 13. Look at that. Well, these three numbers are prime. So, and none of them can go into 15. None of these two can go into 15. So we have to multiply across. 15 times 3, I believe if you do that, you will get 45. And 7 times 13, 7 3s, 21, 7 1 7 and 2 9. 45 over 91 cannot be reduced, I don't believe. 2 can't go into them, 3 can't go into this, 4 can't go into them, 5 can't go into that. So this is the simplest form. Even though these numbers look pretty big compared to what we're normally working with, it is in its simplest form actually. Right? Okay, so 16, we're dividing a whole number by a mixed number. We retain the first one and we write it over 1. We don't absolutely must do that. Just to balance it off, to make it look orderly, we can put it over 1. Change the division sign to multiplication. The 1 and 1/5 as an improper fraction. 5 1s 5 and 1 6 over 5. We are going to invert that. It's going to become 5 over 6. Now we look to see if anything in the numerator can reduce anything in the denominator. And we see that 2 can go into 6 and 16. So 2 into 6 goes 3 times. 2 into 16, 8 times. 8 5s are 40. 1 times 3 is 3. 3 goes into 40, I believe 13 times. 3 into 4, 1. 3 into 10, 3. Remainder 1 over 3. Go to the side. Work out whether it's your multiplication, you need to work out. Your division, you need to work out. Your addition, you need to work it out to the side. Or if your teacher wants to see every single step, then you do it just the same place, right? Do it there and show your steps. Or for this kind of division, you might be able to go to the side, work it out, and put your final answer. So here we have 5 more to go. 2½ divided by 1½. So we're changing them to improper fraction. 2 2s 4 and 1 5 over 2 times 2 1s 2 and 1 3 over 2. Reciprocate that, 2 over 3. The 2's can reduce themselves. 5 times 1 5, 1 times 3 3. 3 goes into 5 once, remainder 2 over 5. 3 and 4/5 divided by 1 and 1/3. 5 3s 15 plus 4, 19 over 5 times 3 1s 3 and 1, 4 over 3. Reciprocate that, 3 over 4. 5 4s are 20, 19 times 3, 3 9s 27, 3 1s 3, and 2 5. And we can get 2 20s out of 57 because 2 20s are 40. So we have a remainder of 17 over 20, which is in its simplest form. And so that is our final answer. 2137 divided by a whole number, 11. 7 2s 14 plus 3, 17 over 7 times. The reciprocal of 11 is 1 over 11. These three are all prime numbers. So they can't reduce each other. And 17 times 1 is 17, 11 times 7 is 77. 5 and 1/3 divided by 3 and 1/5. 3 5s 15 and 1 16 over 3. 5 3s 15 and 1 16 over 5. We reciprocate that, 5 over 16. And the 16s reduce themselves. 1 times 5 is 5, 1 times 3 is 3. 3 goes into 5 once, remainder 2 over 3. And the final example, 4 and 1/9 divided by 1 and 1/7. 4 9s 36 plus 1, 37 over 9 times 7 1 7 and 1, 8 over 7. Reciprocate that, 7 over 8. Actually, none of these can reduce each other, so we're going to have to work them out. 9 8s, 72. 7 times 37, 7 7s 49. 7 3s 21 and 4 25. How many 72s can we get out of 259? We can do some estimation, right? There's 1 72 in 100 with some left back. So 2 would be in 100, roughly 1 and something out of the 59. So let's try 3 times. Sometimes we just have to estimate and check. Let's try 3. 3 2 6, 3 7 is 21. So 3 times, and then the 259 minus the 216, that's 23. So 23 left back over 72. Right? And that's the last example. Okay. So to recap, we're saying when we're dividing mixed numbers, we're changing the mixed numbers first to improper fraction, and we are remembering that to divide a number by a fraction is the same as multiplying the number by the reciprocal of the fraction. The reciprocal of a fraction is where we invert, or we put the top to the bottom to the top. Numerator goes where denominator was, denominator goes where numerator was, right? To divide a number by a fraction is the same as multiplying that number by the reciprocal of the fraction. So to divide by a half is the same as multiplying by 2. To divide by 2 is the same as multiplying by a half. To divide by 3/5 is the same as multiplying by 5 over 3, and so on. We retain the first fraction then, and we reciprocate the second fraction while changing the division sign to a multiplication sign, using the convenience of that mathematical principle. Through centuries of trial and error and doing things, mathematicians realize that you get the same result when you multiply a number by something when you divide a number by something as when you multiply that number by the reciprocal of that fraction, right? We learn these things through trial and error as mathematicians, and it took us sometimes centuries, decades, centuries, millennia in some cases, to come upon what we now see as simple facts. Many of these took lifetimes of rigorous trial and error in one person's career, several generations of mathematicians' careers. So now we can benefit from all of that work with these simple truths. So we're using this simple mathematical principle which says when we're dividing a number by a fraction, we'll get the same result as multiplying the number by the reciprocal, the inverse of that fraction. So that's what we're doing. And since they are mixed numbers, it's easier to work with them in the form of improper fraction. When we get our final answer, however, we change back the improper fraction to mixed numbers. And if the mixed numbers can be reduced, we reduce them to their simplest form. So that's it. If you have been benefited from this video, please drop a comment to say thank you. Please share the video so others can benefit as well. If you have not subscribed, I'm urging you to subscribe so you can have access to all these videos. And let me know if you want me to do a video on any particular topic. Just leave a comment so that I can see, and I'll do that for you. My fellow mathematicians, I'll see you in the next video.